Here's the solution to another problem from section 6.2. It's similar to the first one that we did and has an extra part to it that we should go over here, namely part D is different in this problem. So once again, we're given normally distributed data and we're asked several questions about it. So I'll draw, just for reference, normal distribution curve up here. And again, we label this using the parameters that are given to us. So we're given the mean is 118 and the standard deviation is 15. So we have 118 in the middle, and then 1, 2, 3 tick marks in each direction. It's not a terrible idea to label these. Like this second tick mark will be 148, for example, and second tick mark this way will be 88. So however many of those you can label is good because it gives you some sense for where the numbers are. So the first question asks about the z-score of a blood pressure reading of 140, and so 140 is going to be about here. To answer the question, we need to transfer the picture over to our standard normal distribution. So here's our z-score distribution centered at 0 with tick marks going, oops, 1, 2, 3, and -1, -2, -3. So again, give yourself some tick marks, label them, but this will be our z-score distribution. So to know how to transfer the original picture over to the z-score picture, I need to know what is the z-score for 140. So again, we get the z-score by seeing how far above the mean our value is. So in this case, 140 minus 118 tells us the distance from the mean, and then we divide by the standard deviation, and then that will give us approximately 1.47 is the number that's shown there. So back here on our picture, we need to draw that in. It's about 1.5. So 1.47 as a z-score. Now in this problem, it wants to know the proportion of people with high blood pressure, and so that's measured by going from 140 and higher, obviously. So this is what we're shading to find the probability or the proportion that the probability that a given person has high blood pressure. So we want the probability that Z is greater than 1.47, and that'll correspond to, over here, the proportion of people who have blood pressure at 140 or above. As we said before, the table doesn't give us answers that are shaded to the right like that. So our approach to this is instead to look in the table for the probability that Z is less than or equal to 1.47. This will come from our table. And we get that by just looking up 1.47 in the table and reading off the area. So in this case, that's 0.9292. And again, at the end of this video, if you scroll to the end, I will show you how to look up 1.47 in the table to get 0.9292. So the probability that Z is greater than 1.47 is just the complement of this. So in other words, it's 1 minus this area, 1 minus 0.9292, which is 0. I've lost it now, 0.708. So this would be an okay answer for part A. Now notice on this solution, this is a little tricky when you look at the printed out solutions to these things, because that's not exactly what's here. What is there is what you would get if you did not round this off to 2 decimal places, then use the exact value in a calculator. But of course our table can only work with 2 decimal places of accuracy. So the computer will count both this and this correctly. So if you were wondering, the 2 answers you get from a calculator and from the table are not always exactly the same thing. But the computer knows that both answers should be okay. I'm sorry, so that was part B. Part C asks what proportion is between 100 and 140. Now luckily 140 is already drawn on here, so all I need to do is add at 100 here. And so part C is asking how much area is in between these two things. And so we need to change this over to a z-score question. We already know that the 140 corresponds to a z-score of 1.47. We need to do a similar calculation for the 100, and we find out that blood pressure of 100 corresponds to a z-score of negative 1.2. That's pretty awful. Hang on. So in the z-score distribution, we have the two numbers, negative 1.2 and 1.47. So I'm trying to find out how much area is in between those two values. Again, we can do this several different ways. I'll do this differently than I did the other one just to show you the other option. Notice that we already have on here a picture and an area for how much area is below 1.47. So that would be everything from here down. I don't want to go all the way down, I want to stop here. So what I can do is I can take all the area from here down and then cut off the area from here down. So the probability that z is less than negative 1.2, according to my table, is 0.1151. So that's the amount of area that I have here. I know that the amount of area I have total is 0.9292, so I should be able to subtract the 0.9292 and cut off this much, which is this, and that should be the right answer. So the probability that z is between negative 1.2 and 1.47 is just 0.9292. That's how much area there is to the left of 1.47, and then subtract the amount of area that's to the left of negative 1.2, and that gives me 0.8141. So again, that's a perfectly acceptable answer. Notice that it's not exactly the same answer that's here. If you use your calculator and use the exact, or you use more decimal places for the z-scores in each of the two numbers you put in, then you'll get something that's closer to that. But the computer counts both these answers as correct. Okay, and then part D is asking about the 90th percentile, and so that's a very different question than we've had before. What the 90th percentile means is, where should I draw a line in this picture? Where should my line be so that the total area to the left of my line is 0.9? So in other words, where do I draw the line that cuts off the bottom 90% from the top 10%? And that's actually a very easy question, but it involves reading the table backwards. And so I'll do that on the next slide. All right, so let's start with part D here. I want to know how to get an answer of 0.90. In other words, I want to know where I should draw this line so that 90% of the data is over here and 10% is over here. And so that is answering this question. The table tells us the areas, and so this time instead of taking a z-score and looking up the area, we're simply taking the area and looking up the z-score. If you scan through the table in the interior values, you'll find a number that's close to 0.90. Let's find the closest one we can. I think this is the closest one to 90% in the table. That's only 0.0003 away from being 0.90. All the other ones are further than that. So that's the closest value that I can find in the table to 90%. The z-score that would give me that is 1.28. So this is a true statement. The probability that z is less than 1.28 is, let's say, approximately 90%. And so the question in part D is just what blood pressure reading corresponds to that. And so we know that to go backwards from the z-score to the actual observation, we first need to figure out what 1.28 standard deviations is. That's what our z-score means. So 1.28 standard deviations is, I forgot what the standard deviation is. Hang on. Okay, but the standard deviation was 15. So 1.28 times 15. So that's literally 1.28 standard deviations, and I'm going to say above the mean. So plus the mean was 118. So when we have a z-score, remember the z-score measures how many standard deviations above the mean you are. And so to figure out the observation from a z-score, we just figure out the number of standard deviations plus the mean. So that's about 137. So rounded to the nearest whole number. So 137 as the blood pressure separates the top 10% of the data or the observations from the bottom 90% of observations. That's fine. That's all.